Alright then, welcome to the first tutorial in our new series. Today we're going to have a quick look at some basic logic gates, but before we do that, let me just give a quick overview of the series. We're going to go ahead and cover some logic stuff involving computing, as well as actually do some computer code. I plan to have most of the series be in C++ and in Python, but who knows where it'll go, and so far, we're going to start off with some logic stuff so that we are all on the same page once we actually get to the programming bit. Now, there are three basic logic gates. I have NOT, which in diagrams is represented by a triangle with a circle at the end, AND, which is this, it's like the capital letter D basically, and then OR, which is like a crescent moon. And before we continue, I am just going to go ahead and say that yes, I have done a tutorial on XOR before, and I will be rehashing that tutorial sometime later in this series, but not quite yet, mainly because I just want to go over it in a bit of a I want to go over it the along with NAND, NOR, uh, NAND, NOR, um, and all that. So in and of itself, you can see that this is the only one with a circle at the end, and we're going to get into this later in the series, but that circle means that it's actually the reverse of another gate, which is the reverse of this, which is the buffer gate. Buffer gates are basically just, if it's on, it's on. So let's get ahead and actually look at some of the circuitry. Now this will be the only time, I think, in the series in which I go ahead and use transistors and stuff, or in which I use these symbols and stuff for um, transistors and what are they called? Transistors, and then also for I'm trying to think now. Transistors and resistors, that's what they're called. Yes, resistors. And so let's begin. I'm going to start off with the NOT gate because it's simply the one I want to start off with. It's pretty basic. We have if the input is true, the output is false, and if the output is false, no, and if the input is false, the output is true. So let's have a quick look at how that would work. We have over here our current. Actually, you know what? I'm not going to go with VCC. I'm just going to go with A. We're going to name our current up here A, which is going into here. This thing that I'm making right here is called a transistor. So we have our transistor, and then we have input B and output C. And we also have a grounding over here. So what that'll do is if A is already on, let's real quick like A, VCC, and then B will be our input, C will be our output. So what happens here is, oh wait, hold on, I've drawn this wrong already. This little wire actually attaches up here. And we need a resistor here. So what happens, right? If A is already on and the transistor is received, and we have the resistor here, all that energy is going to go to um, all that energy after going through the resistor is going to go into this transistor, and it's going to go ahead and just ground itself here. But if B is on, that's going to basically stop it from entering the transistor, and it's instead going to go into our C and our output over here. And if I end up getting circuitry parts, I will show you how that works. But for now, let's just move on to our AND gates. Hold on. There we go. So our AND gate is actually going to be a little bit more complicated. And here I'm going to show you a let's real quick have a look at a table for our AND gate. So can you guys see that? Hold on. There we go. So let's put one more layer in at the bottom. And we'll go A, B, and I guess X will be our output this time. So if both A and B are true, X is true. If only A is true, X is false. If only B is true, X is false. And then obviously if both are false, then X becomes false. And we'll get into NAND and all those later, but just for simplicity's sake, let's go into this. So we have our input. Hold on, no. Yeah, we have our input here and our input here, and they're hooked up to two separate transistors. And then we have wire going through here. Let's call this A, let's call this one B, and then we have our current passing down this way into output X. So if both are true, both these transistors will allow the energy to pass through to X. If only A is hold on, these are sideways, aren't they? Sorry about that. That's this way, and then hold on. So basically the current is passing through here. If A is true, it can pass through this gate, but it gets blocked by B. If both A and B are true, it can pass through both gates. And obviously, if only A is true, then it can only pass to B. If only B is true, then it can't even make it all the way to B because it gets blocked by A. So let's go in with our last gate now, and this is actually probably one of the easiest ones in my opinion to actually draw correctly. This is an OR gate. Now it's just like our AND gate, except now the values of A and B on their own will be true. So what that means is before how we only had that one value true, now all three of those values that are not everything is false is going to be true. So what that looks like, we have our two inputs, and let me try to remember how this is done. I have our two transistors, or here. You know what? I'm going to use an entirely separate thing for transistors. I'm not going to be using the standard symbols for this entire thing until we get to the next one where I can actually use nots and ands and ors. But I'm just going to go ahead and make these like that. So this is going to be our transistor. No, that looks dumb. That looks like a deformed euro sign. How about here? We'll make transistors a circle with an X inside of them. So through our little circle with an X inside of them, right? That's our transistor. We have, after that, here. It's a very terrible drawing of it, but this is our output. Have I drawn that correctly? I believe I've drawn that correctly. Hold on. Let me just try to remember real quick. Let's see, yeah, those two transistors. I believe I've done that correctly. Yeah, that should be correct. Let me just make sure. Yeah, it seems like I've done that correctly. Well, either way, what you need to know about the OR gate for this series is that it accepts both inputs A and inputs B to get output X. So electricity moves through this way. Hold on. You know what? You can get rid of that. So electricity moves through this way. If either transistor is activated, we get a positive output. And that basically sums up what you need to know about these gates. The important thing to remember is that all of these logic gates, the important thing to remember about all of these logic gates is that these are going to be how we determine whether or not something happens eventually. So you're going to need to be pretty familiar with how each one works, remembering that OR can take A, B, or A and B, whereas XOR can only take A or B. Stuff like that. Just keep that in mind whenever we go forward with these tutorials. Next time I'll cover, I think XOR, NAND, NOR, all those other ones. So, goodbye.